Hello viewers, in this video I'll be going over the concept of behavioral values of a rational function in regards to the vertical asymptote. This question states, describe how you can determine the behavior of the values of a rational function on either side of a vertical asymptote. Overall, this question will focus on finding the ending behavior of a graph as it approaches the asymptote and finding the vertical asymptote. Factoring rational functions to find the asymptote, checking for pinholes, and finding the ending behaviors from a graph were all taught in the advanced functions course. And specifically, finding which way the y values are approaching, such as whether it is approaching positive or negative infinity, as though x values increase or decrease on both sides of the asymptote were also taught in the advanced functions course. Before we progress, let's review the question one more time and break down the question. Firstly, to start off, describe how you can determine the behavior of the values. From this, we can identify that with the problem given, we will need to find the table of values for a graph to determine the behavioral values / end behaviors. Next, the question says, determine the behavioral values of a rational function on either side of the vertical asymptote. Now from this we can identify that with the example problem given, that the question will be needed to be graphed, check for pinholes, and simplified in order to know or graph the vertical asymptote. We will be using an example problem to solve and better understand this question. We will be using these following steps on the problem. 1. Factor both polynomials. 2. Look for common factors, also known as pinholes. 3. Simplify the expression. 4. Find the roots of the denominator. These will be the vertical asymptotes. 5. Compare the degrees. And 6. Create a graph. The example problem we'll be working with is f of x equals x squared subtract x subtract 2 over x squared plus x subtract 6. Okay, now let's apply these steps to the example problem. For the first step, we will factor both the numerator and the denominator. Factor the polynomials by using the crisscross method. This method was taught in grade 10, so we'll quickly go over this. The majority of this is using guess and check. After I find two factors, I put it into the numerator. You can check that the numerator is correct by expanding it back into the polynomial. If it matches up, then you have got the two correct factors. I will then do the same step for the denominator. And again, after I find the two correct factors, I put it back to the denominator. After both expressions are correctly factored, the second step will be to check for any common factors, also known as pinholes. In this case, it is x subtract 2. A pinhole is a break in the graph. In this example, the pinhole is at 2 and 3 over 5. You can find this by plugging 2 back into the original equation. As you can see, once I plugged 2 back into the original equation, I got 3 over 5. You can use either the unfactored or the factored equation. For the third step, simplify the equation by crossing out any common factors. So in this case, you will be left with x plus 1 over x plus 3. For the fourth step, find the roots. The roots are only from the denominator and not the numerator. In this case, the vertical asymptote is -3. Find this by making the denominator equal to 0. For the fifth step, compare the degrees to find the horizontal asymptote. In this case, it has the same degree on both the numerator and the denominator. Whenever a rational function has the same degree, the horizontal asymptote is always 1. Graphing will be broken up into 3 parts. The first part is to find the y and the x intercept. To find the y-intercept, plug 0 into the x value, because we are trying to find the y value when the x value is equal to 0. In this case, the y-intercept is the point 0 and 1 over 3. In a rational function, the x-intercept is always when the numerator is equal to 0. So in this case, we're going to be taking the numerator, which is x plus 1, and setting that equation equal to 0 to find the x-intercept. And in this case, it was -1 and 0. For the second part of graphing, we are going to be finding our x and our y values. For the x values, we're going to take 2 points to the right of the vertical asymptote and 2 points to the left of the vertical asymptote. This way we have 2 points on both sides. The first point, -1 and 0, was very easy because it's our x-intercept, which we already found in our first step. For the next point, we are going to plug -2 back into the original equation. I recommend using the already factored and simplified equation because it is the easiest one to use, and for the most part you can use mental math. However, for this point I showed you all my steps so you can see exactly how it's done, but for the most part it can basically be done in your head because the numbers work out quite well. And after calculating the last point, you see we have all our 4 points that we are going to use. In step 4, we found the vertical asymptote as -3. So the first thing I'll be doing is drawing that on my graph. The next thing I'm going to do is go and plot all my points. In step 2, we found that the pinhole was located at 2 and 3 over 5. I am making sure to draw my pinhole with an open circle because it is a break in the graph. I also made sure to plot the x-intercept and the y-intercept, as we also found that in the first part of the graphing step. Now I am simply just connecting all my points. I am making sure that the line does not cross the asymptote. I am simply gliding the line close to it, but not crossing it. It is important that the function never crosses the x value of -3, because on the function, that value does not exist. Now, by looking at the graph, we can determine the behavior of a rational function along the vertical asymptote. We can tell this because on the left side of the asymptote, as the x values increase, the y values approach positive infinity. On the right side, as the x values increase, the y values approach negative infinity. If you try this by yourself and still seem to solve for incorrect results, remember, some common mistakes you might find are not checking for pinholes, not factoring properly. However, as stated earlier, you can check this by expanding the brackets to make sure it matches the original polynomial, and lastly, graphing the points, but you can also check this by using Desmos. Desmos is a website where if you put in an equation of a function, it will graph it for you. You can check if your graph matches the graph that was graphed on Desmos. It's important to note that this question and problem can be applied to a future career of your choice. A grade 12 math teacher will need understandings of this question, as he or she is required to teach students terms such as asymptotes, graphing, factoring, rational functions, and determining end behaviors of rational functions. All these concepts learned were all necessary to understand and solve the question. Therefore, it is important for the teacher to have an understanding of the questions and concepts.